The task of lighting design is, according to the requirements of visual work characteristics, correctly select the window opening form and determine the necessary window opening area and location. Since the function of window openings is not only lighting, but also ventilation, explosion venting, and viewing, etc., other functional requirements need to be considered while lighting design. The lighting design is based on architectural lighting design standards. The lighting coefficient and indoor natural illuminance are used as the evaluation indicators of lighting design. The reference plane for industrial buildings is 1 meter from the ground, for civil buildings 0.75 meter from the ground, and the ground for public places. The virtual work is divided into grades 1 to 5, and the average value of the lighting coefficient is used as the standard value. The standard value of the lighting coefficient is formulated according to the outdoor design illuminance value of 15,000 lux. Considering the effect of solar radiation on indoor overheating in summer and the uncomfortable glare caused by it, the daylighting coefficient value could not be higher than 7%. Lighting quality includes lighting uniformity, glare, and light reflectance. Due to the uneven distribution of illuminance within the field of view, it is easy to cause eye fatigue, reduce visual efficiency, and affect work efficiency. Therefore, the illumination in the room is required to have a certain degree of lighting uniformity. Lighting uniformity refers to the ratio of the maximum value of the reference plane lighting coefficient to the average value, and it can also be regarded as the ratio of the maximum value to the average value of indoor illuminance. When the top lighting is used, the uniformity of the first to the fourth lighting grades should not be less than 0.7. Side lighting is impossible to achieve uniformity due to the large variation of illuminance, and the first level visual work is of touch nature, so there is no regulation on uniformity. The position of the side window is low, which is easy to form uncomfortable glare. For this reason, the lighting standard specifies the window discomfort glare index (DGI) according to each lighting level. The glare index mainly depends on the window brightness. The following measures are required to reduce glare. First, the working area should reduce or avoid direct sunlight exposure. Second, it is not advisable to use a bright window as a viewing background. Third, indoor and outdoor shading can be used to reduce the brightness of window openings or reduce the revealing solid angle of the sky. Fourth, it is recommended to make the inner surface of the window structure or the inner wall around the window a light-colored finish. For top lighting, since the glare source is not in the horizontal line of sight, the glare of the top window is generally smaller than that of the side window and the same window brightness, mainly reflecting glare. In order to make the brightness of each indoor surface uniform, each indoor surface must have appropriate light reflectance. The direction of light should be considered to avoid occurring and unfavorable shadows that affect work efficiency and visual efficiency. When the natural light is insufficient, the color temperature of the artificial light source should be as close as possible to the color temperature of the natural light, so as to prevent the color viewing discomfort caused by the color difference of the light source. Since light enters the room through colored glass, the spectral distribution of the light will change, thus changing the color of the light, resulting in poor light color. Therefore, the place where the color needs to be identified should use lighting materials that do not change the spatial distribution of natural light. In place with special requirements such as museums and art galleries, in order to protect natural relics and exhibits from damage, It is necessary to eliminate ultraviolet radiation, limit the value of natural light and total exposure time, and limit the entry of direct sunlight. You can try to check whether the various rooms meet the requirements based on this data and think about what caused it. What is the best material for interior surface? The steps of lighting design are: first, get information; second, select the window opening form; third, determine the position of the window opening; fourth, determine the window opening area; fifth, estimate window opening size; sixth, line out window openings. The data to be selected mainly include the working characteristics and the processor of the room, the location of the working surface, the surface condition of the working objects, the need for direct light, the working area, heating, ventilation, exposure venting, landscape, sound insulation, room size and location, orientation, surrounding environment, etc. The classification of visual jobs and the determination of standard value for daylighting coefficients requires consideration of the most sophisticated and typical jobs and an understanding of dimensions that need to be identified in the job. The form of lighting is related to the position of the working surface. For example, the side window is conducive to the lighting of the vertical working surface facing the light, and the flat skylight is conducive to the lighting of the horizontal working surface. The determination of the lighting form and its orientation needs to consider whether the room allows direct light to enter, which may cause glare and overheating. The determination of window position needs to consider whether the working surface is three-dimensional and smooth, whether it can use light to enhance the three-dimensional sense and improve the visibility, and whether it will produce regular reflections and affect the visibility. It is also necessary to arrange the work area according to the light requirements of different jobs, and arrange the areas with high requirements by the window. Control the area of the north window of the northern heating building and the area of the west window of the northern building to reduce heat loss and west exposure. For the room where there is a lot of dust and waste heat indoors, separate ventilation openings should be set up, and keep a certain distance from the lighting openings to avoid contamination of the lighting openings. Exploring venting windows need to be installed in rooms at risk of exploring to reduce exploring pressure and preserve the load-bearing structure. However, the area of the hose required for exploring venting is often larger than the lighting requirements, which is easy to cause glare and overheating and needs to be dealt with. In the design of the lighting team, the window-to-ground air ratio and the effective daylighting depths are used to estimate the window opening area. The window-to-ground air ratio of civil buildings and industrial buildings is specified as a unified value. The effective depth of lighting is equal to the ratio of the depth of the room B to the height of the reference plane to the upper edge of the window HS. Since the side windows are easy to construct, low in cost, and easy to maintain and use, we should open as many side windows as possible and use skylights to supplement the lack of lighting. When using hybrid lighting, first check the window-to-ground ratio of the side windows and the effective depth of the lighting. Determine the required side window area according to the ground area, and then arrange the side windows according to the actual openable area of the wall, and use skylights for the insufficient part. After light, it is necessary to carry out a lighting check to determine whether the requirements of the lighting standard are met. For the calculation of side lighting, the lighting coefficient is calculated according to the geometric diagram of side lighting calculation. Calculation formula and the parameters provided. The calculation principle of top lighting is lumen method, and the calculation method is the coefficient method. Calculate the lighting coefficient according to the top lighting calculation diagram, the calculation formula, and the provided parameters. The light pipe lighting system is a new type of roof lighting technology, which uses light pipes to conduct natural light from the roof to the interior. Optical components are used in the collection, transmission, and diffusion of natural light, which improves the utilization efficiency of natural light and the possibility of utilization inside the building. It is suitable for basements, no windows, large deeps or space that are not suitable for opening windows. The calculation principle of the light pipe lighting system is also the lumen method, which is similar to the top lighting. When using a light guide lighting system, the uniformity requirement can be met when the distance between adjacent diffusers is not greater than 1.5 times the height from the reference plane to the lower edge of the diffuser. Average lumen output of the system and the corresponding utilization factor need to be considered when calculating in sunny conditions. In lighting design, taking measures to improve lighting efficiency is an important part of effectively using natural lighting. When conditions permit, setting skylights for lighting can not only improve lighting efficiency but also improve lighting uniformity. The light guide device has good lighting effect in the application of tall space and underground space. For the side lighting with large dips, reflector and refraction glass can be installed outdoors to increase the amount of lighting dips in the room. Think about it. Natural lighting not only saves the energy consumption of artificial lighting, but also introduces a lot of solar radiation, which increases the energy consumption of air conditioners. How to solve this contradiction? How to calculate the energy saving of lighting? You can also teach yourself some natural lighting analysis software for architectural design and computation works.